Hello, welcome to this video. This is Unit 3C, Lesson 3, and in this lesson we are talking about graphing polynomial functions from standard form. So just to give you guys a reminder, over here we have the end behaviors of our functions, right? If our function's even, if it's odd, if it's positive or negative, those are kind of the end behaviors of our functions. All right, so without further ado, we're going to dive into some problems. This is the back half of the lesson, so you should have had review in the beginning part of the lesson, okay? So without further ado, here we go. For this example, it says for each polynomial function, state the end behavior, state the values of the zeros with multiplicity if needed, and sketch the graph. So we have a function f of x, which equals negative 2x cubed minus 11x squared minus 12x. And it's important to note in this function, right, we have not factored it. It needs to be in factored form in order to get the zeros and find the end behavior. So what we're going to do is we're going to factor. Now, since it's negative, and I have an x in all my terms, I'm going to factor out a negative x, and what we get is 2x squared plus 11x plus 12. Okay, so I want to go ahead, I want to use the AC method, right? What factors of 24 add up to give us a positive 11? And that is 8 and 3. Okay, so what I'm going to do, I'm going to bring down again my GCF, and now I have 2x squared, and I'm just going to split this term. So 11x becomes plus, we'll do 8x plus 3x plus 12. And it's important to note, right, that your middle two terms, when you split them, that these terms add up to be 11x, okay? So now we'll go ahead, we'll factor by grouping. This is negative x, and I'm going to factor out 2x, leaving behind an x plus 4, and factor out a 3, leaving behind x plus 4. Okay, and we get negative x times 2x plus 3 times x plus 4. And again, you don't have to use this factoring method. If you can factor by grouping, feel free. So now my function is completely factored, and from this, right, I can determine the end behavior. So part A, they said, what is the end behavior? Now, I know that this function, okay, it has 3 zeros. This is x cubed, okay? So I know it's odd, and with odd functions, our graphs are opposite. Okay, our end behavior is opposite. So you can look at these bottom two examples here. Okay, now is it positive or is it negative? Well, let's look at our function. I have a negative term out front. Okay, so this is going to tell me right away that it is negative. Negative. So I know the end behaviors are going to be opposite, or more so that the right side goes down. Okay, so they're opposite, and the right side is going to go down. So that is this case right here. Our function is going to look something like that for our end behavior, okay? So we can say as x goes to positive infinity, our function f of x is going to go up. Actually, sorry, as x goes to positive infinity, our function is going to go down. Negative infinity, okay? This is the right side down, okay? As x goes to negative infinity, our function is going to go up. Positive infinity, okay? This is the left side up. That's the second part. Okay, so there's our end behavior. Part B, what we have to do is we have to determine our zeros. What are our real zeros? Now, because I have x here, I'm going to set that equal to 0. Okay, that tells me a 0. Because I have 2x plus 3, I set that equal to 0, and I solve. And because I have x plus 4, I set that equal to 0, and I solve. Okay, so let me move this up, and we'll go ahead and solve this. So again, our first function, we don't have to solve. here we'll subtract 3 on both sides. We get 2x equals negative 3. And then we'll divide by 2 on each side, and we get x is equal to negative 3/2. And if you're bad with fractions, that is negative 1.5 if you're curious. Okay, and over here we'll subtract 4 on each side to give us x equals negative 4. Okay, so there are our zeros. Those are our zeros. All right, so now we'll go ahead and we'll graph. Okay, so I have zeros. I have a whole bunch of negative zeros, so I'm going to place my y-axis over here. And, whoa, that's a bad x-axis. Let me get a steady hand here. This is going to be rough. Here we go. Need a straight line tool. Okay, so there it is. And I'm going to go ahead and plot my zeros. So I have 1 at 0. I have 1 at negative 1.5, and I have 1 at negative 4. 2, 3, 4. Okay, so with my end behavior going opposite directions, right? As I go to positive infinity, it is going down this direction, and as I go to positive or to negative infinity, is coming from the positive direction. So here is our function. All right, that is f of x. Okay. Here is example 2. And in this example, it's kind of easier to graph. We have 4 terms. Okay, so right away, I'll take it from standard form, right? This is standard form. And I want to put it in factored form. So I'm going to factor out an x squared, leaving behind x plus 1. And over here, we'll factor out negative 36, giving us x plus 1. Okay. This gives us x squared minus, not 1, but 36 times x plus 1. Now, x squared minus 36, that is difference of squares. So x minus 6, x plus 6 times x plus 1. Okay, and we are completely factored. All right, well, part A. What's your end behavior? Well, I know that this is x cubed. This is odd. Okay, but is it positive or negative? Well, it's positive. I don't have a negative coefficient out front. Okay, so that means that the right side is going up. Looks something like this. Okay, so left down, right up. Okay, so let me write this as an ordered pair. So as x approaches the left, that's negative infinity. Our function value, f of x, is going down. That's negative infinity. Okay, and then the second piece. As x approaches positive infinity, right, that's the right. Okay, our function, f of x, is going up. Hey, that's positive infinity. Okay, so there's my 2 end behaviors. The next part, the zeros. Part B, your zeros. I'm going to just set each piece equal to 0. So x minus 6 equals 0. That gives us x equals 6. I'll set x plus 6 equal to 0. I solve, that gives us x equals negative 6. Then I take x plus 1, set that equal to 0. I get a 0 of negative 1. Okay, so what I'm going to have, I'll go ahead and place my y-axis maybe right down the middle here. Okay, and then here's my x-axis. Don't make fun of my lines. They're beautiful. Right, here's y, here's x. Okay, and I'll go ahead and plot negative 6. So 1, 2, 3, 4, 5, 6. And negative 1. And positive 6. 1, 2, 3, 4, 5, 6. Okay. According to our end behavior, left side's going down. And the right side's going up. Ta-da! There it is. That is it. Okay, so I just sketched a function from standard form. Okay, find your end behaviors, find your zeros. That's it. All right, here is a practice problem. Please go ahead and sketch this graph. Remember, you need to determine, okay, is it odd, positive, or negative? Okay, and then what are the zeros? So make sure you factor first. All right, pause the video, please try this one, and then I'll show you the answers. Okay, hopefully you try this example. Here is the image that your graph should look like. It is odd and it is positive, so the n behaviors on the right side are going up, right? Since it's positive, right side is up. All right, here is the second practice problem. Okay, please go ahead. Oh, wait, just one practice. Okay, at this point, we've reached about 10 minutes. I'm gonna go ahead and end this video. Please watch the next video. I will cover the back half, the last part of this lesson. Okay, catch you next time. Peace.